స్టూడెంట్స్ ఈ రోజు మనం మోడల్ ఆన్లైన్ బిట్స్ ఎట్లా ఉంటాయి అనేది ఒకసారి డిస్కస్ చేద్దాం. మోడల్ ఆన్లైన్ బిట్స్ మనకి ఓవరాల్ గా మనం చూసుకున్నట్లయితే గనక మనకి పోలరైజేషన్, ఇట్లాగే లేజర్స్, ఫైబర్ ఆప్టిక్స్, అండ్ దెన్ నెక్స్ట్ వన్ ఏంటంటే మనకి క్వాంటమ్ ఫిజిక్స్. ఈ 3 యూనిట్స్ మీద మోడల్ ఆన్లైన్ బిట్స్ ఎట్లా రావచ్చు అనేది ఒకసారి డిస్కస్ చేద్దాం. ఇప్పుడు దాని ప్రకారం మనం మిగతా విషయాలు మాట్లాడుకుందాం. మీకు ఏదైనా ఆన్సర్ తెలిసినా, ఏమైనా డౌట్స్ ఉన్నా సరే అన్ని కూడా చాట్ లో పెట్టండి, సో దట్ మనం ఈజీగా డిస్కషన్ అనేది అవుతుంది. సార్ గమనించండి డియర్ స్టూడెంట్స్, మనకి ఫస్ట్ గమనిస్తే కనుక ఫస్ట్ మోడల్ బిట్ అబ్జర్వ్ చేయండి ఒకసారి. Which of the following is the unique property of the laser? A. Directional, B. Speed, C. Coherence, D. Wavelength. సో మనం తీసుకున్నట్లయితే ఇందులో డైరెక్షనల్, స్పీడ్, కోహరెన్స్ అనేది యూనిక్ ప్రాపర్టీ ఆఫ్ ద లేజర్ కాబట్టి C is the right answer. నెక్స్ట్ వన్ గమనించండి ఒకసారి. విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ అన్ ఎగ్జాంపుల్ ఫర్ ఆప్టికల్ పంపింగ్? సో మీకు అందరికీ తెలుసు ఆప్టికల్ పంపింగ్ ఎప్పుడు కూడా రూబీ లేజర్ లో జరుగుతుంది కాబట్టి ఆప్షన్ A is the right answer. నెక్స్ట్ చూడండి, when the laser light is focused on a particular area for a long time, then that particular area alone will be heated. Option A true, option B false, option C all of the above, option D none of the above. It is true కాబట్టి option A is the right answer. నెక్స్ట్ గమనించండి, calculate the wavelength of a radiation emitted by an LED light made up of semiconductor material with band gap of 2.8 electron volts. Then ఈ మోడల్ ప్రాబ్లం మనం ఆల్రెడీ క్లాస్ రూమ్ లో చేస్తే ఆప్షన్ డి ఇస్ ద రైట్ ఆన్సర్. 3.8 ఆంగ్స్ట్రామ్స్. నెక్స్ట్ ఫిఫ్త్ వన్ ఈజ్ ఆల్సో ప్రాబ్లం. క్యాలిక్యులేట్ ద నంబర్ ఆఫ్ ఫోటాన్స్ ఫ్రమ్ ఏ గ్రీన్ లైట్ of wavelength 4961 angstroms required to do 1 joule of work. సో మనకి ఆ ఫార్ములా ఈ మోడల్ కూడా మనం చేసినట్లయితే కనుక ఆప్షన్ బి ఇస్ ద రైట్ ఆన్సర్. 2.4961 into 10^18 per meter cube electrons per meter cube. నెక్స్ట్, వాట్ ఈస్ ద నీడ్ టు అచీవ్ పాపులేషన్ ఇన్వర్షన్? పాపులేషన్ జరగడానికి నీడ్ ఏంటి అంటే టు ఎగ్జైట్ ద మోస్ట్ ఆఫ్ ద ఆటమ్స్. సో ఆప్షన్ ఏ ఇస్ ద రైట్ ఆన్సర్. నెక్స్ట్ గమనించండి, విచ్ ఆఫ్ ద ఫాలోయింగ్ కెన్ బి యూజ్డ్ ఇన్ ద వైబ్రేషనల్ అనాలిసిస్ ఆఫ్ ద స్ట్రక్చర్? వైబ్రేషనల్ అనాలిసిస్ గురించి మాట్లాడినప్పుడు మనకి ఇచ్చిన ఆప్షన్ చూసినట్లయితే మేజర్, లేజర్, క్వాడ్జి, ఎలక్ట్రికల్ వేవ్. లేజర్ ఇస్ ద రైట్ ఆన్సర్. ఆప్షన్ డి ఇస్ ద రైట్ ఆన్సర్. నెక్స్ట్ గమనించండి, సప్లై ఆఫ్ ఎనర్జీ ఆటమ్స్ ఫర్ ఎగ్జైటేషన్ ఇస్ కాల్డ్. ఏమంటాం మనం దాన్ని? పంపింగ్ అంటాం. ఆప్షన్ సి ఇస్ ద రైట్ ఆన్సర్. Next, in a helium neon laser, the ratio of helium to neon gas molecules is one of the order of helium to neon ఎంత ఉంటుంది మనకి? 10:1 కాబట్టి ఆప్షన్ సి ఇస్ ద రైట్ ఆన్సర్. నెక్స్ట్, లేజర్ రేడియేషన్ ఈజ్ పాలిక్రోమాటిక్, హైలీ డైరెక్షనల్, మోనోక్రోమాటిక్ అండ్ హైలీ ఇంటెన్సిటీ. సో ఆప్షన్ బి ఇస్ ద రైట్ ఆన్సర్, హైలీ డైరెక్షనల్ అండ్ హైలీ ఇంటెన్సిటీ. నెక్స్ట్ గమనించండి, విచ్ పంపింగ్ మెథడ్ ఈజ్ యూజ్డ్ ఇన్ హీలియం నియాన్ లేజర్? ఆప్టికల్ పంపింగ్, ఎలక్ట్రికల్ పంపింగ్, కెమికల్ పంపింగ్, డైరెక్ట్ కన్వర్షన్. హీలియం నియాన్ లేజర్ కాబట్టి ఎలక్ట్రికల్ ఎక్సైటేషన్. ఆప్షన్ బి ఇస్ ద రైట్ ఆన్సర్. ద లేజర్ బీమ్ ఎమిటెడ్ ఇన్ ద ఫార్మ్ ఆఫ్ ఫ్లక్చువేటింగ్ రేడియేషన్, కంటిన్యూస్ స్పెక్ట్రమ్, పల్స్డ్ అవుట్పుట్, ఎక్స్పోనెన్షియల్లీ డిక్రీజింగ్. సో దిస్ ఇస్ ఇన్ ద కేస్ ఆఫ్ రూబీ లేజర్ కాబట్టి మనకి పల్స్డ్ అవుట్పుట్ అనేది వస్తుంది. నెక్స్ట్ గమనించండి, the wavelength of laser light is, in the case of ruby laser, 694 nanometers. That is the right answer, option A. The energy levels of which ion or atom or molecule are responsible for the lasing action? In the helium ruby laser lo chromium 3+ ion. Option B is the right answer. Next, helium neon laser is a 2-level laser, 3-level laser, 4-level laser. Helium neon is always 4-level. Option C is the right answer. Helium neon laser gives colored laser, so red color light. Option B is the right answer. The core diameter of the single mode step index optical fiber is Option B is the right answer, 8 to 10 micrometers. Next, the light ray travels through the optical fiber by the principle of total internal reflection. So option C is the right answer, right? Next, all of you observe it. The expression for the numerical aperture is A, that is square root of n1 square minus n2 square. Next one is the refractive indices of step index fiber are varies, constant, non-uniform, none. So it is always constant. The refractive index of step index fiber is always constant. Option B is the right answer. Next, for a long distance communication, the suitable optical fiber is silica fiber, gray index fiber. For long distance, gray index fiber is always suitable. So option B is the right answer. Next, observe the next model online bit. Numerical aperture depends on acceptance angle, critical angle, refractive angle, none. Acceptance angle. Option A is the right answer. In the step index optical fiber, the signal travels in step index, helical, parabolic, zigzag, none. So step index always it is zigzag. So option C is the right answer. If delta is the fractional difference of the refractive indices of the fiber, then its numerical aperture is n1 into square root of 2 delta, n1 into 2 delta, n2 into 2 delta, etc. So option A is the right answer. Option B is the right answer. Option B is n1 into square root of 2 delta. That is the right answer. Next, V number represents exact number of modes of the propagation through the fiber, proportional number of modes of propagation. V number always represents the proportional modes. So option B is the right answer. Next model bit is the fiber has core and cladding refractive index of 1.45 and 1.44 respectively. The refractive index of difference is already మనం ఈ మోడల్ ప్రాబ్లం క్లాస్ రూమ్ లో చేసాం కాబట్టి ఆన్సర్ ఈజ్ 6.896 into 10 power minus 3. That is the right answer. Next, 27. Micro bends and cracks present in the optical fiber cause mode of coupling, loss of light intensity, change of internal reflection angles, all of the above. Yes, all of the above, because in the optical fiber, the cracks leads to the mode of coupling, loss of light intensity, change of internal angle, etc. So option D is the right answer. Next, the light sources used in the fiber optic communication are LED, semiconductor laser, photosensor, both A and B. Yes, in the fiber optic sensor, generally we will use LED and semiconductor laser. So both A and B is the right answer. Option D is the right answer. Next, optical fibers are made with optical fibers are always made with dielectric materials. Option D is the right answer. Next, optical fibers carry very large information compared to the copper cable communication because large thickness of the fiber, extremely wide bandwidth, extremely less bandwidth, none of the above. So it is option B, extremely wide bandwidth. So option B is the correct answer. Next one is the electrical conductivity of a semiconductor lies in between conductor and insulator. Option B is the right answer. Next, if the Hall coefficient is positive, then the semiconductor is a p-type semiconductor. Option B is the correct answer. Next, the indirect band gap semiconductor is silicon, germanium, and germanium, gallium arsenide. Option D is the correct answer. Next, diffusion coefficients and mobility relation is given by option A, Hall equation, option B, Fermi-Dirac, option C, Einstein, option D, Maxwell. So option C is the correct answer, Einstein relation. Yes, when a small amount of pentavalent impurity is added to a pure semiconductor, then the resulting semiconductor is called option B, N-type semiconductor. Option B is the correct answer. Next, electrical conductivity of a semiconductor at absolute temperature, absolute zero temperature is 0. Option C is the correct answer. Next, the Einstein relation between the diffusion constant and the mobility of an electron is dn by mu n, or dn by mu e is equal to k suffix b into t by e. Option A is the correct answer. Next, in an intrinsic semiconductor, the Fermi level A lies at the center of the forbidden gap. Yes, option A is the correct answer. Next, most of the commonly used semiconductor material is A, silicon. Option A is the right answer. Next, at room temperature, a semiconductor material is a perfect insulator, a conductor, slightly conductor, any one of the above. Option A is the correct answer. Perfect insulator. For silicon, the energy gap at 300 Kelvin is 1.1 electron volt. Option C is the right answer. The forbidden gap for a germanium is 0.72 electron volt. Option B is the right answer. The process of adding the impurities to a pure semiconductor is called doping. Option B is the right answer. The pentavalent impurities like antimony, arsenic, bismuth, and phosphorus added to the intrinsic semiconductor are called. So if we add the pentavalent, then you will get donor or n-type impurities. We call it as donor or n-type impurities. So option D is the right answer. Impurities like boron, aluminum, gallium added to the intrinsic semiconductor to form p-type doped semiconductor. Option B is the correct answer. In a n-type semiconductor, the position of Fermi level is higher than the center of energy gap. Option C is the right answer. The mobility of the electrons in a material is expressed in the unit of mobility is always expressed in the form of meter square per volt second. So option B is the right answer. In a metal, the electrical conduction is by the electrons and holes. The conductivity decreases with the rise in temperature. The conduction band is empty, none of the above. Option B is the right answer. The conductivity decreases with the rise in temperature in the metal. Next one is the energy gap in a semiconductor. Option A increases with the temperature. Option B does not change with the temperature. Option C decreases with the temperature. Option C decreases with the temperature is the correct answer. The next one is a semiconductor is formed by a covalent bond. Yes, option A is the correct answer. The semiconductor has temperature coefficient of resistance. So semiconductor is always having negative temperature coefficient of resistance. Hence option C is the right answer. A semiconductor has generally dash number of valence electrons, 4 valence electrons. Option D is the right answer. The strength of a semiconductor crystal comes from option C, electron pair bonds. As the doping of pure semiconductor increases the bulk resistance of the semiconductor. So option C decreases. The random motion of the electrons and holes due to the thermal agitation is called option A diffusion. That is the right answer. In the depletion region, a p-n junction, there is a shortage of dash, acceptor ions, holes, and so option B is the right answer. Both holes and electrons. The strength of the semiconductor crystal comes from option C is the right answer, electron pair bonds. The semiconductor behave at absolute zero as insulator. Option B is the right answer. Next, the de Broglie wavelength of the particle of mass m, charge particle E is given by de Broglie wavelength. That is option B, lambda equal to h by square root of 2 MeV. The velocity of matter wave varies with the velocity of material particle. Option B is the right answer. Option C, the concept of matter waves is given by Schrodinger. Is given by Schrodinger. Next, de Broglie hypothesis states that the wave nature of light, so particle nature of light, dual nature of light, all of the above. Option D is the right answer. The wavelength associated with the de Broglie is known as wavelength of electromagnetic wave. No, it is known as matter wave. Option C is the right answer. Schrodinger time independent wave equation is a classical differential wave equation. Option A is the right answer. If the momentum of a particle is increased 4 times, then de Broglie wavelength will become decreases 1/4 time. That is option D is the right answer. De Broglie wavelength of an electron which has been accelerated from the rest to the 100 volts potential difference. Then it is given by 1.227. That is option B is the right answer. 1.227 angstroms. Next, according to wave mechanics, a material particle is possessed with a wave packet. Option B is the right answer. The wavelength of the matter wave is independent of option C, charge of the electron. That is the right answer. Assuming the velocity to be the same, which particle is having longest wavelength? Electron, proton, neutron, and alpha particle. Option C is the right answer. Neutron has the longest wavelength. Next one is the rest mass of the photon is option D, infinity. And then a photon and electron have the same wavelength. Then option B, electron has greater momentum. A photon and electron has the same frequency. Then option D, none of the above. Next, dual nature of matter waves predicted by option D, Heisenberg. Uncertainty principle states that the error in the measurement is due to option A, dual nature of particles. Yes, option A is the right answer. Which of the following can act as both particle and as a wave? Photon, electron, neutron, all of these. Yes, all of these act as a dual nature of matter and energy. Next, a proton with an energy of 2.05 mega electron volt has a de Broglie wavelength of, yes, this model problem already we performed in the classroom. Option C is the right answer. 2 into 10 power minus 14 meters. Next one is the velocity of X-rays in the vacuum is option D, that is greater than the velocity of light. No, none of these. So velocity of X-rays is in the vacuum is none of these. Option D is the right answer. X-rays. X-rays were discovered by option C, W.L. Bragg. And then the walls of the particle in a box are supposed to be option D, infinitely hard and infinitely large. The wave function of the particle lies in which region? Option C, 0 is less than x is less than a, or 0 is less than x is less than L. So option C is the correct answer. For a particle inside the box, the potential is maximum at x equal to L. That is nothing but x equal to A. So option A is the right answer. The condition for the required for a wave function is single valued, finite, analytical. All of the above. Option D is the right answer. The Schrodinger wave order differential equation is second order. Option A is the right answer. The wavelength of a photon with momentum 10 power minus 23 kilogram per meter is this model problem already performed in the classroom. It is comes around 0.66 angstroms. That is option B is the right answer. So option B is the right answer, 0.56 angstroms. So dear students, this type of model online bits you may come across in the mid-2 examination. So all of you prepare well. All the best.